NFPA 75, the standard for the protection of information technology equipment, addresses concealed electrical installations under raised floors. Section 11.4.5.4 states that conductors must be installed in adequately protected raceways, metallic cable trays, or electrical cable assemblies with conductors specifically listed for use under raised floors. Additionally, Section 11.4.6 stipulates that electrical wiring and interconnections must comply with the applicable requirements of the National Electrical Code (NEC). The NEC provides further guidance on acceptable wiring methods. Section 500.11 pertaining to equipment and wiring for Class 1 locations mandates that all rigid metallic conduit, electrical metallic tubing, intermediate metal conduit, flexible metallic conduit, metal-clad cable, and non-metallic raceways be provided with a termination fitting listed for the purpose for the type of cable or conduit used. Flexible cords, flexible cables, and other flexible connections are prohibited from being used as a substitute for fixed wiring or conductors. Furthermore, regarding fire-rated rooms, NFPA 101, the Life Safety Code, Section 9.5.4.11, generally requires that a computer room housing computers and associated peripheral equipment be located in an area protected by an approved automatic sprinkler system. Several case studies underscore the hazards associated with improper electrical installations in data centers. Firstly, the data center fire at the University of California, San Diego. A fire was caused by a short circuit in a whipcord installed under a raised floor. The fire rapidly spread to other equipment, resulting in considerable damage. Secondly, the data center fire at the National Weather Service in Phoenix, Arizona. A fire originated from a faulty power strip connected to a whipcord, leading to the fire spreading to other equipment and causing significant damage. Based on NFPA 75, the NIC, and NFPA 101, installing whips with only rubber-coated cords under a raised floor for IBM equipment is not permitted. The computer room is typically required to be a fire-rated room. The case studies emphasize the importance of adhering to safety regulations to prevent fire hazards. Now, let's delve into the specifics of these standards and codes to gain a clearer understanding of the requirements. NFPA 75 aims to minimize the risk of fire and protect information technology equipment in the event of a fire. The standard provides requirements for the construction, protection, and occupancy of information technology equipment areas. The requirements for electrical installations under raised floors are crucial for preventing fires and ensuring the safety of personnel and equipment. The use of raceways, metallic cable trays, or electrical cable assemblies with listed conductors provides a physical barrier to protect the conductors from damage and prevent the spread of fire. The NEC offers detailed guidelines for electrical wiring and interconnections. It covers various aspects of electrical installations, including wiring methods, overcurrent protection, grounding, and equipment listing. Compliance with the NEC is essential for ensuring electrical safety and preventing electrical hazards. The prohibition of flexible cords, flexible cables, and other flexible connections as a substitute for fixed wiring or conductors is intended to prevent overheating, short circuits, and other electrical problems. Fire-rated rooms are designed to contain a fire within the room and prevent it from spreading to other areas. NFPA 101, the Life Safety Code, specifies requirements for the construction, protection, and occupancy of buildings to provide a reasonable degree of safety for fire and similar emergencies. The requirement for an automatic sprinkler system in a computer room is intended to suppress a fire quickly and prevent it from escalating. Now let's explore the reasons behind these regulations. Firstly, data centers contain a high concentration of electronic equipment, which consumes a significant amount of electrical power. This high power density increases the risk of electrical fires. Secondly, the raised floors in data centers create a concealed space where fires can spread undetected. The lack of ventilation in this space can also contribute to the rapid spread of fire. Thirdly, the presence of combustible materials such as cables, wiring, and paper in data centers can fuel a fire and increase the damage. These regulations also outline approved methods. Firstly, use rigid metallic conduit or electrical metallic tubing, also known as EMT. These provide a robust grounded enclosure for conductors, offering physical protection and a path for fault current. Secondly, intermediate metal conduit, or IMC, provides similar protection to rigid conduit but is lighter and easier to work with. Thirdly, metal-clad cable, or MC cable, consists of insulated conductors encased in a metallic sheath. It offers flexibility and ease of installation while providing grounding and physical protection. Fourthly, electrical cable assemblies with conductors specifically listed for use under raised floors are pre-engineered systems designed for data center applications. They typically include cables, connectors, and mounting hardware. In addition to these wiring methods, it is crucial to use listed and labeled equipment. Listed equipment has been tested and certified by a recognized testing laboratory, such as UL or ETL, to meet specific safety standards. Labeled equipment bears a label from the testing laboratory indicating that it has been tested and certified. Now let's also examine the risks associated with non-compliance. Firstly, fire hazards are increased with improper wiring, creating a risk of electrical fires that can damage equipment, disrupt operations, and endanger lives. Secondly, electrical shock hazards also increase the risk of electrical shock to personnel who may come into contact with exposed or damaged wiring. Thirdly, equipment damage. Improper wiring can damage sensitive electronic equipment, leading to costly repairs and downtime. Fourthly, business interruption. Fires and electrical problems can disrupt data center operations, resulting in significant financial losses. Fifthly, code violations. Non-compliance with electrical codes and standards can result in fines, penalties, and legal liabilities. To mitigate these risks, it is essential to implement a comprehensive fire safety plan for data centers. This plan should include the following elements. Firstly, fire detection and suppression systems, which install automatic fire detection and suppression systems such as smoke detectors and sprinkler systems. Secondly, proper wiring methods. Ensure that all electrical wiring is installed in accordance with the NEC and other applicable standards. Thirdly, regular inspections. Conduct regular inspections of electrical systems to identify and correct any potential hazards. Fourthly, employee training. Provide employees with training on fire safety procedures and the proper use of fire extinguishers. Fifthly, emergency preparedness. Develop and implement an emergency preparedness plan that outlines procedures for responding to fires and other emergencies. Now let's discuss some best practices for electrical installations in data centers. Firstly, use only listed and labeled equipment to ensure that all electrical equipment meets safety standards. Secondly, install wiring in raceways or cable trays to protect conductors from damage and prevent the spread of fire. Thirdly, properly ground all electrical equipment to prevent electrical shock hazards. Fourthly, use appropriate overcurrent protection devices, such as circuit breakers and fuses, to protect circuits from overloads and short circuits. Fifthly, separate power and data cables to prevent interference and ensure reliable data transmission. Sixthly, label all cables and equipment for easy identification and maintenance. Seventhly, maintain accurate documentation. Keep detailed records of all electrical installations, inspections, and maintenance activities. Now let's move on to the importance of regular inspections and maintenance. Regular inspections and maintenance are crucial for ensuring the continued safety and reliability of electrical systems in data centers. Inspections should be conducted by qualified electricians or electrical inspectors who are familiar with data center electrical systems and applicable codes and standards. Maintenance activities should include cleaning equipment, tightening connections, replacing worn or damaged components, and testing systems to verify proper operation. By following these guidelines and best practices, data centers can minimize the risk of electrical fires, electrical shock hazards, and equipment damage, ensuring the safety of personnel and the continuity of operations. The information provided here is for general guidance only and should not be considered a substitute for professional engineering advice. Always consult with a qualified electrical engineer or electrical contractor to ensure that electrical installations in data centers comply with all applicable codes and standards. Furthermore, it is crucial to stay updated on the latest revisions and amendments to the NEC, NFPA 75, and NFPA 101. These codes and standards are periodically updated to reflect new technologies, best practices, and lessons learned from past incidents. Staying informed about these changes will help ensure that data centers are equipped with the most effective fire safety measures. In conclusion, electrical safety in data centers is a multifaceted issue that requires a comprehensive approach. By adhering to the requirements of NFPA 75, the NEC, and NFPA 101, implementing best practices for electrical installations, and maintaining a robust fire safety plan, data centers can significantly reduce the risk of electrical fires and protect valuable assets and personnel. Now let's look into specific scenarios and examples that might come up. Suppose you are working on a data center project, and the electrical contractor proposes using flexible cords to connect equipment under the raised floor, arguing that it's faster and cheaper than installing conduit. Based on what we've discussed, you should immediately reject this proposal. Explain to the contractor that the NEC prohibits the use of flexible cords as a substitute for fixed wiring in this application. Emphasize the importance of using approved wiring methods such as rigid conduit or metal-clad cable to ensure electrical safety and prevent fire hazards. Now consider another scenario where you are inspecting a data center and notice that some of the electrical panels are not properly labeled. This can create confusion and increase the risk of errors during maintenance or emergency situations. You should immediately bring this to the attention of the facility manager and recommend that all electrical panels be properly labeled with clear and accurate information. The label should indicate the circuit served by each panel, the voltage, and the amperage rating. Now let's consider a situation where you are upgrading the power distribution system in a data center. During the upgrade, you discover that some of the existing wiring is outdated and does not meet current code requirements. You should recommend that all outdated wiring be replaced with new wiring that complies with the latest edition of the NEC. This will ensure that the electrical system is safe, reliable, and capable of handling the increased power demands of the data center. Next, let's discuss the importance of surge protection. Data centers are particularly vulnerable to power surges, which can damage sensitive electronic equipment. It is essential to install surge protection devices at the service entrance and at each individual piece of equipment to protect against power surges. The surge protection devices should be properly sized and rated for the electrical system. Now let's delve into the topic of grounding. Proper grounding is essential for electrical safety and for preventing equipment damage. All electrical equipment in a data center should be properly grounded to a common grounding electrode system. The grounding system should be designed and installed in accordance with the NEC. The grounding conductors should be sized appropriately and securely connected to the grounding electrodes. Now let's consider the importance of arc flash protection. Arc flash is a dangerous electrical phenomenon that can occur when there is a fault in an electrical system. Arc flash can cause severe burns, injuries, and even death. It is essential to implement arc flash protection measures to protect workers from the hazards of arc flash. These measures may include wearing personal protective equipment, using insulated tools, and implementing lockout/tagout procedures. Now let's talk about the importance of power quality. Power quality refers to the stability and reliability of the electrical power supply. Poor power quality can cause equipment malfunctions, data loss, and downtime. It is important to monitor power quality and to take steps to improve it if necessary. These steps may include installing power conditioners, uninterruptible power supplies, and harmonic filters. Now let's consider the importance of uninterruptible power supplies, or UPS systems. UPS systems provide backup power in the event of a power outage. They are essential for maintaining the continuity of data center operations during power outages. The UPS system should be sized appropriately for the load it is intended to support and should be regularly tested and maintained. Now let's discuss the importance of generator backup. Generator backup provides a long-term source of backup power in the event of a prolonged power outage. Generators are typically used in conjunction with UPS systems to provide a comprehensive backup power solution. The generator should be sized appropriately for the load it is intended to support and should be regularly tested and maintained. Now let's consider the importance of fire suppression systems. Fire suppression systems are essential for protecting data centers from fire damage. These systems can include sprinkler systems, clean agent fire suppression systems, and pre-action fire suppression systems. The fire suppression system should be designed and installed in accordance with NFPA standards. Now let's discuss the importance of security systems. Security systems are essential for protecting data centers from unauthorized access and theft. These systems can include access control systems, surveillance systems, and alarm systems. The security system should be designed and installed to meet the specific security needs of the data center. Now let's consider the importance of environmental monitoring systems. Environmental monitoring systems are essential for monitoring the temperature, humidity, and other environmental conditions in data centers. These systems can help to prevent equipment failures and ensure that the data center is operating within its optimal environmental parameters. The environmental monitoring system should be designed and installed to meet the specific monitoring needs of the data center. The electrical contractor's assertion that they are allowed to install whips to the IBM equipment under a raised floor using only rubber-coated cords is inaccurate. The NEC and NFPA standards require conductors under raised floors to be installed in adequately protected raceways, metallic cable trays, or electrical cable assemblies with conductors specifically listed for use under raised floors. The use of only rubber-coated cords is not permitted as it does not provide adequate protection against physical damage, fire hazards, and electrical shock. Similarly, the claim that the computer room is not required to be a fire-rated room is also likely incorrect. NFPA 101, the Life Safety Code, generally requires computer rooms housing computers and associated peripheral equipment to be located in an area protected by an approved automatic sprinkler system. While the specific fire rating requirements may vary depending on the occupancy classification and building height, the intent is to provide fire protection to safeguard lives and property. It's crucial to review the local building codes and regulations to determine the exact fire rating requirements for the computer room. To ensure compliance with the relevant codes and standards, it's recommended to consult with a qualified electrical engineer and fire protection engineer. They can assess the specific requirements for the data center project and provide guidance on the proper electrical installations and fire protection measures. The case studies highlight the potential dangers of using whip cords under raised floors in data centers. A short circuit in a whip cord caused a fire in a data center at the University of California, San Diego. The fire spread quickly to other equipment and caused significant damage. A faulty power strip plugged into a whip cord caused a fire in a data center at the National Weather Service in Phoenix, Arizona. The fire spread to other equipment and caused significant damage. These case studies underscore the importance of following the NEC and NFPA standards for electrical installations in data centers. Using approved wiring methods such as conduit or metal-clad cable can help prevent fires and protect valuable equipment. Also, here is a final summary of the key takeaways. Firstly, the NEC and NFPA standards require conductors under raised floors to be installed in adequately protected raceways, metallic cable trays, or electrical cable assemblies with conductors specifically listed for use under raised floors. Secondly, the use of only rubber-coated cords is not permitted as it does not provide adequate protection against physical damage, fire hazards, and electrical shock. Thirdly, computer rooms housing computers and associated peripheral equipment are generally required to be protected by an approved automatic sprinkler system. Fourthly, consulting with qualified electrical and fire protection engineers is essential to ensure compliance with the relevant codes and standards. Fifthly, adhering to the NEC and NFPA standards for electrical installations in data centers can help prevent fires and protect valuable equipment.